In the production network, it is the administrator who selects the switch to be the root bridge. We don't allow system to elect the root bridge on its own, because if the tiebreaker is the lowest MAC address, most likely it is going to be the oldest switch that is going to be selected to be the root bridge, and we want to avoid that kind of situation. So the way we do it is by selecting the root bridge manually, and there are two ways of doing it. One way is, let's just say for the argument's sake, I want to select the root bridge to be switch 1, and in case of this one's failure, I want switch 2 to be its secondary root bridge. So what I'm going to do here is I'm going to jump to switch 1, and there's two ways of doing this. Since we're running per VLAN spanning tree VLAN 1, specify which VLANs we want to be the switch to be the root bridge for, and we say priority. Now, priority will be the values given in that range. However, system expects us to start with 0 and use increments of 4096. So if I say 43, it's not going to work. It says no, the values allowed are these. So one of these values. Second thing we can do, or it's a macro command, so I can say, instead of priority, I can say root, and there's two options, primary and secondary. If I make this one primary, what's going to happen is show spanning tree and root detail. So I am the root bridge right now, signified here, and with this command, root primary, system made priority 24,577 for VLAN 1. If I do this, use the same command here on switch 2, only parameter will be secondary, VLAN 1 root secondary. It's going to show spanning tree about this bridge detail, please. So this switch has now priority 28,000. So it's a second in turn to become the root bridge. So if the 24,000 fails, obviously this one is the lowest value right now, priority. It's going to become the root bridge. Now, the root guard is the feature that protects our root bridge from losing its position in the network. So let's just, for the argument's sake, assume that I can maybe connect switches into our network, but I don't want those switches to become the root bridge. So what can I do? For example, let's just say for the argument's sake, this access switch on all ports, I could do this command, and the port is E12. What I'm going to do here on this particular switch, I'm going to say interface E12 spanning tree guard root command. So that is the command on the port. Once this command is on the port, if this port receives BPDU that is inferior, so it's higher priority than current root, nothing's going to happen. If, however, I receive the frame that is superior, which is the lower priority than current roots, it's going to put the port in a blocking or root inconsistent state. Let's emulate that real quick. So bridge 1 protocol IEEE protocol IEEE bridge 1 priority. Let's make it better than the root bridge. We'll make it 0, and interface E02 bridge 1 enter. Now I'm sending BPDUs. So since the priority is better than the current root, this port should go in a blocking inconsistent state. And we can see that right here. So if I look, this is a funny thing, because if I look into show interface E12 status, okay, it says it's connected, it's working. But if I do show spanning tree and interface E12, I'll see that the port is currently in a root inconsistent state. If there were more, the command is show spanning tree inconsistent ports. It shows which ports are inconsistent. The moment I stop sending those BPDUs, superior BPDUs, so if I say no, and I'll say So this will unblock the port. Now what I'm gonna do is now check the switch, and in a few seconds, it'll take probably 15 more seconds, the port should go from inconsistent to unblocked, and it will work just fine. There you go.